Okay, guys, welcome to week 3 of the 6 weeks free Node.js backend development training. Today is Saturday, so we'll be looking at TypeScripts, TypeScript Basics, and then after that we'll look at start going to Node.js proper. I believe that will be where we'll start creating our servers, and from there we'll move over to next. We'll do some hands-on coding, then move over to Express.js. So not much ado. Let me start. Let me share my screen and start doing some coding. I'll share some slides with us so that we just have a brief discussion on on TypeScript and see how we will to practice on it. All right. So all right. This is my slides. Sorry guys, let me bring up my slides. Don't worry, after the lecture we upload the slides to our GitHub repo so that everybody can have access to it, and I'll also upload the video. Alright, okay, let me share the screen. Entire screen. Okay, give me a thumbs up if you can see my screen. Thumbs up if you can see my screen. Good, good. All right. So our previous classes we've discussed JavaScript, and we've done some labs, some demonstration on JavaScript. We discussed the basic types. We discussed functions and everything, classes, and we did some OOP coding on JavaScript. So we move over to TypeScript. Basically, TypeScript is just JavaScript, all right, but it's JavaScript with types. So everything you do on JavaScript you can do on TypeScript, and it will be valid. So it's from my slides here. This says JavaScript is a superset of TypeScript is a superset of JavaScript that is compiled to JS. That is JavaScript. JS is JavaScript, and has benefits like type safety. It helps catch errors during development. So when you one of the benefits of TypeScript is that it helps you to catch errors. Like when you start, probably if you work on small applications, you may not see the benefit, but when you start using a TypeScript to build larger applications, now you start appreciating the benefits of TypeScript. So why use TypeScript? The first one is it detects bug at compile time, not runtime. All right. So when you do your coding in TypeScript, there are some bugs that you may not cache. When you do your coding in JavaScript, I mean, there are some bugs that you not cache, you will not be able to detect until you run your code. But in TypeScript, when you use TypeScript, you'll be able to cache those bugs at compile, because when you run your TypeScript, when you code in TypeScript, before you run the code, before you run your code, it will first compile to JavaScript before running. So at that compilation time, it will check for bugs, for errors, types and the rest. If it sees anyone, it will throw you, it will notify you, then you'll be able to catch them and solve the bugs. All right, so that's the one of the benefits. Then also it adds IDE auto completion and better readability. Yeah, when you start using it, you see some of the auto completion features it adds to your code, and it helps you to enjoy coding. And also it supports OOP, that is object oriented programming concepts, like we discussed in our JavaScript class when we discuss about classes and objects. You can see that we did some OOP also with JavaScript, but in TypeScript they add some extra flavor, some extra items to it, so that you can be able to practically do OOP conveniently with TypeScript. Right, so that's basically that's that. So let's go to the next one. Yeah, basic types. So let's in our previous class, in our JavaScript class, we started with the types. Before you, in every programming language you want to learn, the first thing you learn is the basic data types that are there. All right, so we discussed JavaScript data types. We have the string, number, boolean, the big int that was introduced later in JavaScript, the undefined, null, and the symbol. Those are primitive types. Then we have the non-primitive, the arrays, the objects, what have you. All right, so the set and map. So in Java, in TypeScript, we have the same. All right, we have almost the same with some extra things added to TypeScript. So we're going to see them all along here. So just like in from my slide, just like in JavaScript, TypeScript has primitive data types and non-primitive data types. So primitive data types are just like we know in JavaScript. They represent both integer and floating numbers. All right, so this is how we code in JavaScript, in TypeScript, sorry. So in TypeScript, you put your you use your keyword, your variable definition, the defining keyword, which is let or const or var, anyone you want. Then the name of the variable, which is age here in this in my slides, which is age. Then you see this colon. Then you see number. All right, this column and number that you see here is type annotation. It's called type annotation. We are trying to annote, give this our variable a type that it is going to, this variable is going to contain, is going to handle number, any value of number. If you try to assign string to this variable, it's going to, TypeScript is going to throw you an error. All right, so as you can see, this is how we define it, and it doesn't discriminate whether it's an integer or a floating number. As far as number, they are all the same in Java, in TypeScript. Then the next one is string. String represent textual data enclosed in single quotes, double quotes, or backticks for template literals. So like we discussed in JavaScript also. So this is how you annotate your types, all right, in TypeScript. So then the next one is boolean, which is a logical value, which is true or false. All right, so that is the first three. Then the next one, yeah, so null represent the intentional absence of any value, any object value. So if this is how we define it. Let's say in your code you may try to say, okay, I want this variable to either be null or hold a string or hold another value, another value, another type of value. Then we are noted this way. We're going to discuss, we're going to in the future, in the coming topics, we're going to see the symbol, why what this actually mean. But just know that this data variable can hold two values. It can either hold a null value or a string value. All right, so and as you can see, it's now initialized with a null value. Okay, so then the next one is undefined. Undefined represents a variable that, as we discussed in JavaScript, it represents a variable that has been declared but not yet assigned a value or a property that doesn't exist yet. So as you can see, you can either assign a number or undefined. So as we declared it here, but we didn't assign any value for it. As you can see, there's no assignment operator here. There's no equal to something here after we annotate the type here. There's no equal to. So basically, TypeScript or JavaScript, we give it an undefined value. Okay, so the next one is symbol. Symbols represent a unique immutable value that often used as object key. So this is how we also use annotate symbol in TypeScript. Then a big int, as I said that it was introduced later. This is also, you can do that in, like we do in JavaScript, you can do that in TypeScript also. So it's a senior brother. I'll call it a senior brother to number. All right, so it helps to when you are working on a project that has to deal with large numbers. So instead of using number, you can use big ints. All right, then you know how to handle your precision and the rest. Then now we go over to the object types. That's the non-primitive types. All right, just like we have in JavaScript. We have the array. This is how we define array in Java in TypeScript. I hope you able to see. I can make this thing. Sorry guys, I just hope you can see. Okay, so this is how we annotate. We give array type annotations here. We're going to see this in lab, so I'm just trying to introduce it to us so that we will be familiar with them. So this is how we annotate array in TypeScript. Then this is we have tuple. Tuple represent an array with a fixed number of elements whose types are known at specific position. So there's something about take note of these two items here, this array and tuple. In JavaScript we don't have tuple, all right? We just have array, and in TypeScript they look the same. They are, in fact, they are the same data structure. They are the same data structure, but in this tuple here, in array can expand, all right? Is You can expand it. You can, if you start with three value inside your array, you can give it extra values, you can put more extra into it, all right? And it's often in TypeScript. In JavaScript you can put different values in array, like you can put number, string, and an object inside one array, put them as many and as you like, all right? Different types. But in TypeScript here, the array you can't actually do that for array, because if you want to annotate your array type, you say number and you give it. See how we annotated it here? So it means that this array will hold only numbers. All right, the first array will hold only numbers. If you try to put string into it, it will TypeScript will flag it down for you. Will give you a compilation error. All right, then the names array, see how it's being initialized, how the type is being annotated. Then see, we can only assign numbers to it, all right? So, and we can only assign strings to it, and you can assign as many as you want, all right? This can grow, but you maintain single types. That's how TypeScript manages array. But in tuple here, it's kind of another way, another logic. You can use different values. Like you can use on this example you see string and number, all right? You can use different value, but the length must be known. Like as it's stated here, the length must be known. Okay, so you can't add extra anything again to it, to this tuple. You must just use a string and number for it, and you can't add any other thing. So that's the difference. That's how TypeScript decided to manage array and tuple for JavaScript. So the next one is enum. Enum provides a way to define a set of named constant values. So we're going to discuss this enum. All right, we're going to demonstrate them. So just look at how is a keyword enum. So we use it to define some kind of values that we want, like set constants. Then the next one is any. Any is a keyword in JavaScript, in TypeScript, sorry. So it's kind of like if you use any in it will annotate a variable. If you give any variable type any, in fact it will start behaving like JavaScript variable. TypeScript will ignore any type checking, not do any type checking on that value. So you can put anything on that value, on that variable. Okay, so you can put anything, like as you see in this example, dynamic value has any as type. Then we initialize with hello string, then later we give it number. So TypeScript will allow you to do it because you gave it any keyword, you give it any type, so to allow you to do that. So, and yeah, these ones, now these three keywords that are next is we have void, never, and unknown. They are special to TypeScript. All right, so void represents the absence of any type, typically used as the return type for functions that do not return a value. So we're going to see it in practice, just for when you don't want to return anything. Void, you don't want to return anything, a function does not want to return anything, so you just use void for the return type. We're going to see that in demonstration. Then we have never. Never represent the type of values that never occurs. Often, functions that throw an error, so we're going to see that. Never is just when your function is sure to throw an error. So you use never. Never, you can never. I don't think you just code and put never and use never on your code. Probably it's when you start seeing that a function is running never, you know that something is wrong, it's throwing an error that you need to go and debug. Then unknown is kind of similar to any, but it's safer to use unknown. Okay, it's safer to use unknown. Like instead of using because when you're working on a project, the reason why you use any for as a variable type, it means that you don't know what that variable is, the value, the type of value is going to have. It may be a string, may be a number, so you don't know. So you just want a variable to hold any value that will come into that variable. So you use type any as type. All right, but JavaScript TypeScript now say okay, instead of using any, it's better use unknown, because unknown in the future is that when you use unknown, when you want to, like, if you assign a value, if you assign a value, before you be able to use that variable that you assign that value, you do some kind of narrowing, like you do a type check. If you don't do a type check before using that variable, TypeScript we give you a compilation error to let you know that you need to check the type, so that you know that it's safe to use, or what any method you're calling that variable is valid. Okay, so that's unknown. Then the next one is object. Object is very obvious. Just give it type and give it type of object, and you give it the define an object literal or anything. So the next one is type aliases. Just all about many things about types. We have type aliases, union types, intersection types. So in TypeScript, we have union types, like I showed you, we saw earlier. A value can either hold two types of value. A variable, sorry, can either hold two types of value. Like as you see in this our value, in this our definition here, this value variable can either hold a string or a number. All right, you can give it a string or you can give it a number. So you can't give it any other type again from these types you define. So basically that's called union types. Union types allow a value to be one of several types. Okay, you use this symbol, use this symbol to combine types. All right, you give it different types. You can add many types that you want. You can add other kind of types. All right, so then the intersection types, an intersection type combines multiple types into one, requiring the value to satisfy all constraints. So this is how intersection, you use this ampersand sound sign to assign to denote intersection types. Then types aliases is just like giving your types name, the types that you have defined. You give it name. Like in this example, we use this type keyword id equal to this string or number. So basically what we're saying is that any variable that we're going to assign this type alias of id to is going to either hold a string or a number. Okay, so that's we're going to do all these things in practice. Okay, so we have function types. This is how you define our function typing. You define your function, the parameters, you give them types, and the return value. This is how see where we place the return value here. When you want to annotate the return value of a function, this is how you put it, and this is how you give the type you give the parameters typings: a of type n number, b of type number. The return type will be or is of type number also. All right, then interfaces is just like defining types for your objects. This is how you use the keyword interface, then the name of the interface, then the curly brackets, and the names of the properties and the types. Okay, so that's for functions and interfaces. So I think let's do these ones then before we'll come back to the OOP, the class and the rest. So let's start with all right, let's start with the basic types. So we're going to say let's say All right, guys, let's quickly do this because whatever after this TypeScript lecture, uh, every other thing we're going to be writing is on TypeScript. We're not going to build anything with JavaScript. Okay, I don't encourage you if you are working with if you are working in the JavaScript ecosystem to write your codes in JavaScript. Use TypeScript. Actually, write it in JavaScript, but use TypeScript because it's better, safe than using TypeScript than using JavaScript. Okay, so we're going to start basic types. Hope you guys can see my screen very well, right? Let me go back to see. All right, guys, give me thumbs up if you can see my screen, please. All right, so okay, so let's quickly breeze through Java these types. Then we'll go over to Node.js. I believe that's what we've been waiting for. So if we define annotates, so this is how we define this is how we annotate types here. I gave you this age type number. Then see if I try to assign string to it, as you can see it's already flagging. So it says type string is not assignable to type number. All right, string is the type of the value I'm trying to assign to it. So it's telling me it's not assignable to type number. Type number is the type of my variable that I defined. So this is an error. It's very the error is very descriptive. So we should see the error, be able to know where the problem is. So but I can give you something like 5.6. It will work. There's no issue. All right. Then we have something like this. We can also do hex value here. If I do JavaScript will allow you to do hex. All right, this is a hex value. This number, all right, in hexadecimal format. Okay, so JavaScript will allow you to do this. TypeScript also, that's going to allow you to do that. Even JavaScript big number. Now there's what we call, well, let me not, there's what we call type inference. Okay, you see here I didn't give it a type annotation. I didn't annotate any type to it, but JavaScript TypeScript already inferred type number here from the value I gave it. All right, so if I try to give it string or array, you see type never is not assignable to type number. Okay, so it's I can't change because already I have given it type number here. So TypeScript already given it automatically, behind the scene, give it a type of number. As you can see as you can see from the pop-up here, is type let number of type no, let num of type number. So I can't do this even if I didn't annotate any type to it. TypeScript will give it type from the value I initialize with it. So that's basically the thing there. So the next one is string. So this number. So let's look at string, the same thing. Do I have name here? Okay. Think you're having a okay. Sorry, let me. I want to start debugging that now. Let me just start something new. Sorry guys, I need to spin up a new folder. All right, so this type string, if I do this again, if I do this, if I demonstrate the type inference also, okay, okay, so this is it. If I try to do email, all right, so type error. So then the next one is boolean. um, all right, basically everything we do, we did in in JavaScript. Then we have the big ints. So no, I don't want to take too much time here. So we can just go over to um, over to node proper. So this is big ints. If I try to give it another number, let's say 5, it will throw an error. Type number is not assignable to big. So this type checking here is is the main thing about TypeScript. Okay, is the main thing about TypeScript, because if it's in JavaScript, it will allow you to assign your value to do anything you want. And along the line in your code, you may start coding some bugs that you yourself may not even know about, that you won't even be able to catch them during you only be able to catch them in your when your code starts running and the rest. Then symbol is almost the same thing. Then null then let's see, let's look at sorry, okay, well, let me annotate it. if if you annotate, give a value, no, it means you can't take anything again. All right, can't give it anything. So basically those are the types. Let's go to the next thing. I don't want us to spend much time here. Let's go to the next topic. I think we talked about, okay, let's talk about the object types. All right, so now let's, okay, where did we talk about the arrays and object types? Okay, now let's start with the array. Okay, okay, now this is what I was trying to explain to us. I can give the numbers here and give it number. No, now see, I can add more number. I can push in more number, put in more number to the array. Okay, more numbers, all right. But if I try to, let's try to put a string. You notice something here. Now I'm getting an error. An error. It says argument of type string is not assignable to type number. Okay, so this is it here. Okay, but in JavaScript, you are able to do this in JavaScript without any issue. Okay, so that's the issue here. Then let's look at the tuple. But look, there's another hack to this thing. Let's say I can still do something like this. Now, instead of using only number here, annotating only number array, I use this union type. I use the union type to say, okay, this array can either have a number or a string as its element. Okay, so with this now, I'll be able to push in. I'll be able to push in any numbers and string. Let me use on shift. Push and on shift are the same. Push adds to the end, while on shift adds to the beginning. All right. So guys, this will work. Okay. So as you can see, I'm not running my code because we need to when we want to we need TypeScript to run code to execute the code, but I don't want to do that now. I just want us to demonstrate this type because this is the main thing about TypeScript. As you're coding, if you are doing anything wrong, it will be to be giving you, it will be hinting you that something is wrong with your code. So that is just for it. Then let's look at tuple. This is array. Let's look at tuple. Okay, now we say now this is how you define you annotate your tuple. String number. Okay, then we say Alice. As you can see, it's valid this way. But look at, if I try to add in something, let's see. Okay, I wish I were able to run this code now for us to see the the result of this push. All right, but know that this is a tuple and you can only add in string and number. If let's say I try to put in, let's say I try to put in an object. As you can see, it's telling me no, I can't put in an object type. Argument of type this is not assignable to type string or number, so I can put in extra string, but I can't put in an object, right? Okay, then I think we need to verify if the length will grow. So now the next one, let's look at enum. In JavaScript, there's nothing like enum. We don't have enum, but in TypeScript we have enum. If you are coming from other programming languages, you know that there is enum. Like in Rust, there's enum. This is how we define enum. Okay, so I have defined enum. These values, this is how you define it. You give it enum name, you give it the name of the enum. Now is a convention that if you are naming your enum, you capitalize the word like the first letter will be capital, so that in your code you know that it's an enum. It's just a convention. You can give it, you can use small letter, nothing will happen. It's still valid. But so um this type enum, if I do this now, if I have annotated this move variable to be a type enum, if I want to give it a value, I will do this, then I'll pick from it. All right, now I can't, let's say I can't initialize, I can't give value to this move now, any value this apart from this enum. So let's say I try to do, okay, no, okay, so it's telling me I can't assign string. All right, type of this is not assignable to type direction. Okay, so you can also give, see this will work. Okay, so what if I want to give, like, I've told the enum that okay, each of these should I say the properties of enum are, I've given them a value. So what if I want to do something like, I want to give it right. This right is here, this keyword, this right word here is what I'm trying to assign to it, but it's telling me no, that I can't give it. So there's a hack in TypeScript. Just do this and it will allow you. So you are telling TypeScript that okay, this word I give here, it's also part of the direction enum, so you should allow me to use it. So TypeScript will allow you, we leave it for, we allow you to do that. Okay, so that's for that. Then let's go over to type aliases. Guys, hope, let me know if my network, okay guys, can you see my screen? Give me thumbs up please. I don't know, so that my, it won't be like my network is down. All right, okay, good. So I want to brush this thing up so that we can go over to Node.js. I believe that's what we've been issuing for. Okay, so type aliases, like I discussed, we can do something like this. Use another variable. Okay, so okay, so look at this keyword here. Look at this type keyword. All right, this is type alias. I want to define a type, like I want to create another type from the normal basic JavaScript type, like string, number, and the rest. I want to create a type, by doing some manipulation with the types that are already existing. Okay, with types that are already existing. So I want to. That's why I'm defining a type alias. This is known as type alias. That's giving name to another, to types. All right, creating custom types. So this is what basically it is, type alias. Then let's say I will do this. Okay, so now I can now do something like this. I'll say user ID will be of type ID. So if I'm assigning user type, it will be of type ID. It's either a string or proper number. Can do it this way. So guys, take note of this thing. When we start writing our project, we're going to see a lot of these things that we're going to be using, we're going to be coding, because this is basically the fundamentals, the background, the fundamental of the project and everything. So then we can do something like, I want a place. Okay, let's do this. Let's use this example. Type person, type contact. As you can see, it's object type. Type employee is person and contact. Now this is, I'll call this union type, because I am combining these two types. Then this one will be intersection type. So what this means is that if I am assigning a value to employee, it must satisfy this person type and this contact type. So the value I'll be assigning to employee must have name and phone in its object. Okay, because this is our object type. This is an object type. As you can see, it's curly brackets, an object type. So if I say employee is type employee, right? If I want to give it values, I must specify then phone, okay. So this is how I will satisfy it. If I didn't give it this, it's going to complain, because it's expecting phone property. All right, it's going to complain. But you see, now look at what I did here. This question mark, all right, in object types and interface, you can make things optional by giving it question mark. Okay, so what this question mark means is that, okay, it means what it means that, okay, it is acceptable that phone property will not be there, but if it is there, accept it. But if it's not there, no problem, don't complain about it. That's what I am telling TypeScript. Okay, if you look at the pop-up here, you see the tooltip. You see phone is type string union undefined. It means that it can be undefined and it can still be string. But if I remove it, you see that phone is type string alone. So let me add it back. So what it means is that I can still add phone. I can add phone and it will work. But if I try to add another thing, let's say address, it will complain that it doesn't know what address is. Address is not part of its type. Okay, it's not defined in its type, so it will complain. All right, so that's basically type interface and optional typing. So okay, there's also literal types. Let's say you want to status. We can do this. Okay, you can do this. We see we defined HTTP status to be either 200, 400, 500. Any other value will not be acceptable. If I do something like 503, like I'm trying to give it 503, it will accept it because it's not part of it. So Despite the fact that the types of values I specified here are numbers, this variable is not going to accept any other number. It's not going to accept any other number apart from the ones I specified here. So this is what we call literal types. These are called literal types. Okay, or let's give it something in its value. Okay, we can also do that for, we can also use a string for that. Up, just like we demonstrated with the enum. So here, if I give it something like, see, as you can see, it's giving me pop-up like the options are specified. I already know the options. It's the variable has to needs to take. Okay, so if I put any number there, it will work. But if I put, okay, let's say I do this, it's going to complain. All right, it doesn't know what I'm saying, give me the red line. So basically that is type aliases. Then let's go to functions and see how functions can be defined, are being typed in TypeScript. Function typing. So if I want to define, right, so this is my function. I need to give it parameters. Let's say I say string greeting. Okay, let's see. Okay, as you can see, it's telling my, the TypeScript already giving me a notification that parameter name implicitly has an any type. So if you didn't give a type to if you didn't give a type to a value, to a variable, and you didn't initialize it, it didn't initialize it in the function, it's automatically taking type any. So what I need to do is just give it a type, and this is how we give it type. Okay, colon the type, this two colon type. Now I can make this greeting optional by giving it question mark after the name. All right, then because I am making it optional, I put an optional value here that if greeting is not defined, is undefined, I'll use hello here. um Other way I can do that is initializing the if I remove the question mark, it means that this is optional. If I don't give it any value, I'll take it to take hello here. Okay, this is actually optional. Greeting now is optional. Like if I call greet, let's say, okay, it can take only the name, only first, the first argument. It can take only first argument. But if I remove this, TypeScript will telling me that it needs another value, another argument here. But if I do this, if I come and add question mark here, the red line will go away because it's now still optional. So this is how we define function and the parameter types. Now, if I how do I annotate the return value? Okay, let's say if I do something like this here, let's say I put a number here now. So I need to annotate returning number. But if I do something like TypeScript will complain because this void here I'm annotating, it means that I am not returning anything. Okay, I'm not supposed to return anything, but I am yet returning number from the function. So this type annotation is wrong. Okay, so it's only when to use void annotation is as a return type is when you are not returning anything. If I remove this return, comment it out or remove it, it will now work because I'm not actually returning anything. Okay, so that is about that. Okay, let's look at interfaces. Interfaces actually work with objects and also classes. So to define an interface, you use the keyword interface. Then you can also use type here or do this. You have to assign the value. But if you use interface, the type is actually defining an object type, but interface is actually interface, and you can extend can implement with class, can implement class in it. So if I do this read only id, so what this read only means is that any variable, any object I initialize, I give a type of this user must have id, and the id will not be changed once it has been initialized. All right, it cannot be changed in the future once it has been initialized. So let's just do small demo on that. Name, string, age, number. I think that's that. Let me just do. Then new user is type user. So if I do something like this, name, you can see it's telling me that I am yet to. So it's done. So if I try to, if I do something like this, let's say age, I can update the value of age, but I can't do. If I try to see, it will tell me no, it's read only because of this keyword I put here. It's read only. I can't change it. Okay. Then I can actually extend an interface with another interface. Sorry. Okay, what this is saying is that I want to take everything that user have and add it to whatever I'm going to add to this interface. So if I do something like departments, sorry, okay, if I do something like departments, now if I now define something like new employee of type employee, hello, yeah,
Hi, Christian.
yeah,
Sorry
yeah,
to interrupt you. I was
okay,
going to ask, when we're done with this class, we get access to the code? Are you going to push this code to GitHub so we can
Yes,
just take a
yes.
look at?
Of
Okay.
course.
All right. Thank you.
Of course, I will share the code, even the slides too. I think we're going to be discussing something on GitHub probably by tomorrow, so that those of us who are not familiar with GitHub will be able to use, interact with the GitHub that I'm going to be sharing with us. We're going to do something on GitHub tomorrow. All right.
Okay. Thank you very much.
Okay. So now let's initialize. If I do this, okay, type then name and age. Now you see, okay. Then if I do, so as you can see, this is, if I remove this, it will tell me that I am yet to define to add something. Look at it, property department is missing in type, blah blah blah. All right, so it means that this emp extends user and with extra property of department. So when I am define, and since I annotated this new employee type, and I've defined the other properties. All these other properties are on you on the user interface. They are on user interface, but this one here that I added to EM interface, I haven't included it. That's why it will give me an error. So I need to include it for it to work. So basically, guys, you can extend interface with another interface. Okay, that's that. Then as for interface, then let's move over to classes. All right, we it's very important because our code base is going to be in class. We're going to be writing our all our things in class, but we'll start with functional programming, then go over to classes. So let's discuss classes and OOP concepts. Just like as we discussed in JavaScript, there are some extra things that TypeScript added to their own class definitions. So let's just discuss them. Okay, TypeScript enhances JavaScript classes. Let's look at the time. Okay, TypeScript enhances JavaScript classes with type annotations and access modifiers. All right, so there are three main access modifiers in JavaScript, in TypeScript. In JavaScript we discussed two. We have two: the private access modifier and the public. Okay, and the private, you to know private, there's no keyword for private or public. There's no keyword to do that. So we use the hashtag as the hash symbol to annotate the private. So in class, in JavaScript class, if you see any variable that starts with hash, you know that that variable is private and you can't access it outside in any outside the class. If you initiate an object with that class, you can't access the property of the class with that is private that started with hash. So but in TypeScript, they don't use hash. What they use is keyword proper. Like we have public, we have private, and we have protected, and they are different. They do different things. Public is the default. If you define a variable or a property or a method without anything, you don't give any keyword, automatically by default to public can be accessed outside the class when you initialize the class with an object of the class. Then there's private. Private is the one we know in JavaScript with hash. All right. Private in public allows access to class members from anywhere. Then private only allows access to the class member from within the class. No outside access. Then protected allows access to the class member from itself and any classes that inherit it. So you just the parents, if a parent has a protected member, the child can access the class, and that's then keywords that support OOP concepts. Okay, so in TypeScript we have the extend. Classes can extend each other. We can extend a class, um, just to to extend, to add some things, just like we extended the interface from with another interface in that last example. Then implement interface can be used to define a type a class must follow through the implement keyword. Like it's just like abstracting. All right, it's just like you want to you create an abstract of the class, and you give it some properties that the class must define. A class must define when they follow that interface. So you use the implement keyword. So we're going to see an example of that. Then the override. This concept that you're seeing here, they are the concept that support OOP. Like OOP is inheritance, encapsulation, abstraction, and polymorphism. These things here helps to achieve those OOP concepts. Okay, like the extent here, you can the extent can help you inherit from your parent. The child can inherit from parent. The implement can work as abstraction when you create an abstract. Then the override here can be a polymorphic system to when a method overrides the other method. When a method in child class, a child object, a child class here overrides a method in its parent class. So it's that's polymorphism. So use the override keyword. Though it's optional, override keyword is optional when you want to um, do that. So let's have a demo on these things. Okay, classes, guys. Let's grab this. We're going to be doing building our code in class. Okay, so let's start with the interface, the extend, and the rest. Implement. Um, so I'm going to give a very elaborate example. So we have, let's define an interface. Um, so this is an interface, all right, workable. Then I gave it a walk. This is a method, called a function. Normally, this is how we defined. We can do something like this. From our previous example, this is normal variable. Why this is a method? All right, this is method, function method. Okay, this is how I define it. I remove this one. Then let's say I have a class employee. Okay, let me just use this one. Implement workable. Now, as you can see, since it's saying implement workable, so TypeScript is now telling me that this employee class indirectly implements interface workable. Then property work is missing, so it means that I need to define this. Since it's this class is defining the is implementing the workable interface, I need to define this method here. So I can now do something like this. All right, so this is how I'm trying to implement the workable method now that a workable interface defined. All right, so this is it. You see the error is gone. So that's just about that on implementation. Like, then um, let's define some public variables. Okay, I need to do that in the constructor problem. Then let's do this protected. I think we're almost done with. So the three keywords are here, are defined here. Then see, these errors will go away. Just I need to. So it's telling me that I must initialize them in my constructor. So if I do something like this, name the salary, then I give them type of string number, then I do this dot. All right, so you can see the errors are gone. Okay, so take note of this keyword. This here means pointing to the instance of the class. This is just class is just like a template of an object that you want to create. You're going to create. Okay, so when you start using the class to create objects of that class instance, objects, so you're going to be having, you're going to create multiple objects of that class. So the key, this keyword means that this keyword it means that a particular instance of the class is what you're referring to. Okay, instance A of this class has its own this, instance B of the same class has its own this. So it's just referring to instances of that class. Okay, so that's the logic there. Then if I, okay, let's just do something here. um this name. All right, so okay guys, so um this the name is public, department is protected, so I can use name, and I can use the two of them in the class. Also I can also use salary here in my class. Let's do that. I'm not returning anything here. I don't let me just I don't want to return this template retriever. If you're wondering, salary name, dollar. So I'm not returning anything, so the return type will be void. I'm not accepting anything, so I won't define any parameter. So guys, this is, I can still access salary here in my class. Okay, so let's see. Okay, get through. Oh, let me return the type I'm returning. So I have defined the class here. So let's start initializing instances. with the class. So if I say, oh, let's extend the class. Okay. So now class is now inheriting from, it's now extending its parents of emp employee. So we can take some argument from the class. Salary. Okay. Sorry. So because I need to call super now, why? Okay, let me finish before I explain. I'll do this thing. All right. So guys, as you can see, this there's a new keyword here, super. Super means calling the class that manager extends. All right. If a class extends another class, and TypeScript actually supports single supports a single extension of classes, like you won't allow you to extend another class with joining with this one. It won't allow you, so you can only extend single class with another class, so at an instance. So this super here is referring to this class that manager extends. So if I give this super here is just like, since I'm calling this super, it's just like I'm calling the constructor of this. And as you can see, I gave it these three arguments: the name, department, and salary, just as it's defined in its constructor, so that this members that manager inherits, you understand, inherits, can be initialized by the parent. Then this extra member here that the manager has in addition will now be initialized by its own constructor. So I don't know if it's confusing. So just take note of this style, this thing here. Call super to give it the class, the to give it the arguments that the parent class initializes on its constructor. So now, why do I need to do this? I can actually, if I don't have anything, okay, let's say if I don't have anything here, all right, and I don't have anything here, I can actually not have a constructor. I can actually not have a constructor in my class. Like if I define my class probably with no extra member, I can just extend this my the parent class here. Then what I'll just do is probably add some extra member, add some extra methods and the rest. Then I'll be good. If I can even have something like let's say, okay, so if I do this, as you can see, I'm not initializing. I'm not trying to. I already initialize this variable, this member here. Okay, I already initialized it. I don't need to initialize it from the constructor. And at the same time, this method is on its own, like is there. So because I don't need to initialize this member here from the constructor, and so it means my constructor didn't change. Like I don't want to change my constructor, so it means that I can ignore the constructor if it doesn't change from what from what the my parent here that I'm extending has. Okay, there's nothing additional I want to do. Like here initially I wanted to add x team size because I have team size I need to initialize when I'm initializing my manager class. But since I don't have it, I can ignore the constructor and just extend the class and do some other things. But if I want to initialize some extra member, just like team size, I will need to create my own constructor of the class of my class. I need to create the constructor and the member I want to initialize. Then when I do that, in my new constructor, I need to call the super member, the super class, so that while I'm calling the super, I'm initializing the super, that's the parents, the super, the inherited class constructor. All right. If I don't do this, there will be that's going to complain. All right. As you can see, it's going to complain. If I remove this, okay. Yeah. Say constructors for derived classes must contain a a super core. So basically, that's just the logic there. All right. So we're going to see this a lot in our code in our project. So that is for the extend inheritance and the rest. There's a lot of okay. Now let's do another thing here. See this class here. This class get through. If I initialize a member of if I initialize what I'm trying to say here is that okay, hold on, let me salary team size. So if I call this get through here, if I call this get through, it's going to return employee. All right, it's going to return employee for me, but my role, this class is a manager class. All right, so it's not an employee class. The role is manager role. So what do I need to do? Simple. I just need to override get through to return what I want. Okay, so if I call get through now, it's no longer going to return employee. All right, it's going to return manager. Okay, because I have overridden it. I can add a keyword here, override is acceptable, but if I didn't add it, it's optional. Okay, so it means that I want to override this method here that the parent class has. I want to override it. This is actually polymorphism. All right, polymorphism. This class now has different from the get row has different behavior. So that's that. Then which other thing do I need to demonstrate? Okay, then all right. So guys, I think we don't need much. This is just basically what I need us to know here. If you have any question, you can ask. Then we'll just have to look into them. So let's go to the last topic I have on basics now. Um, Generics. What's the time? Okay. By 2:30 we'll go on a break. Let's refresh. Then when we come back, we'll go into Node.js. Then we'll discuss modules on Node.js, the important modules that we need to look at. Then when we discuss the modules, then we'll start. That's where we'll start writing our servers, generics. Okay. let's look at these slides. Just something. Okay, generics allows developers to create reusable components that can work with a variable of data types while maintaining type safety. Yes, generics can be implemented with function interfaces, class, and the rest. Okay. Now, when you say generics, sometimes some people used to scare some people away, like what's the in annotation and the rest. But it's kind of easy, simple if you understand it very well and just have a proper look. So it's kind of, instead of using type, a concrete type, define type on a function or interface to define your type, the type of a data value. Instead of using a concrete type, you use a generic type. So that generic will like be a placeholder for the type. Okay, just like a placeholder. You're not actually defining a type. You're telling that okay, this type should relate to this and this. Okay, let's just see a demo from these slides here. Let's code out the function. Um, let's say okay. Guys, in case you are new to JavaScript or TypeScript, don't don't be overwhelmed with whatever you're seeing. Everything just needs practice. Everything just needs practice. Um, you get familiar with whatever we are doing. So this is it now. Okay, you see, I define normally if I want to define a function. Let's say I want to define this exact function. Let me comment it out. Let's say value, I give it a parameter. I want to return that same parameter. Annotate string. Okay, now if I want to call this, if I give it a number type, see it's going to complain arguments. Wait, let me add more values. If I give it argument of type number is not assignable to type string. Okay, so this function that I define here cannot work with string, cannot work with number, it can only work with string. Okay, it will not complain if I give it a string value. Okay, so if I want to, if let's say I want to do the same logic, I want to create this same logic. Okay, but I want it to be number, I want to accept number types. I'll have to define I'll have to define another function that does the same thing but with different type. Okay, so the same logic but different types is just the difference. Okay, now generics will not make you like we help you to code, just write one function for these two types. Okay, so that's basically what generic does. Instead of using defining number and sorry instead of defining two different functions with different types. Okay, generics we now generics will just tell you put the only additional thing here is this curly this sharp brackets here, or should I call it sharp parentheses here. So it's this is the additional thing with the t here. This t it can be any letter. You can use u if you want. Then it must be inside. All right, whatever you put here is what you're going to use within your function. Okay, if you use s, it should be s also. All right. So this whatever you're putting here is the main generic item here. Okay. So here now I can use identity for anything. This identity function I can use it for string, I can use it for numbers, and it won't complain. You see, it won't complain, just like before, this first one complained that I'm using number when I'm supposed to use string. Okay, but here I can use number, I can use string, and the type safety is still there, it's top notch, it's still checked. Okay, I can even use array. Okay, yes, I can use array to do my thing. All right, so that's generics, and there's it's more, there's some more concept, some it's more elaborate than this. This is just a way, an introduction. Probably when we start using it in the future, you understand better. Okay, you can also do this for this same logic for array. Let's do this. Okay, see if I notice that normally we initialize our array. Um, if we want to, sorry about this. Okay, mixed. No, no. Let's use it for interface. This here. Okay, so this is how we use generics for interface. All right. So the type you give here, let's see if this will work. So with this interface, for example, you can just do something like voiding. Okay, so this user interface I different here is just causing me problems. So this is how we use in the interface. Then, if I want to reuse it, can do something like this number, then it will take number. Okay, so name here, name property will take any type of value that I give it on the on the generic entity. So this is the demonstration for generics. What's the time now? So we are done with basics of JavaScript, guys. Our next topic will be Node.js. We'll start discussing modules on Node.js, and we'll start building our endpoints, creating our servers. Okay, so please let's meet back by 2:45, right? 2:45, guys. Are we cool, guys? Are we cool? 2:45, please. Let's please. If you're dropping message when I start. Okay, hold on. Okay, okay. Let's meet back by 2:45. Thank you. Let me just pause record. Okay, guys, welcome back. So we are going to basically discuss um, two things. We're going to discuss modules. We're going to discuss npm node package manager. Then we'll now discuss node. All right. So let's start with modules. All right. What are modules? I think I have modules. Yes. Okay. Can you see my screen? You can see my presentation, right? You can see my slides. Okay. So a module, all right, a module is just a file that contains reusable code like variables, functions, or classes and can be imported or exported to other files. All right, simple. It's very simple. So all these things here that we've been creating, basically, we are just creating them. All right. So if I try to export, maybe I define a function here and I try to export it so that I'll be able to use it in another file, in another JavaScript file or TypeScript file, then it's that file is now a module. All right, that's the logic. So any from the definition, it's just a file that contains reusable code like variables, function, or classes that can be imported or exported to other files. All right, so that's basically the definition. Okay, there are two module systems in JavaScript. There is the common JS, known as CJS, and there's ES module, known as ESM or ES, whatever. So, common JS CJS is used in older versions of Node.js, like Node.js version, like from version 13 down. All right, file extension are the file extension for CJS are normal, like if you write .cjs, any file name .js or cjs, it's known as common JS by default. If it's JS by default, it's common JS. In Node.js, then ES module, all right, it's used in modern browser. It's modern JS. It's of recent JavaScript, modern JavaScript. Then it's used in browser, basically in browser. Then anything from Node 13 upward, you can use ES module. Now the file extension is .mjs. If you write a file, if you write in a JavaScript file and you give it .mjs extension, then its type module is ESM. Or in your JavaScript, in your project, in your Node project that you have packages, so we'll get to know what packages is in a minute.
This is
Then if you if you define a type, a type property with a value of module in your package JSON, then your project will be interpreted as ES module. Okay. Um, Now there are ways. What is the major difference between these two modules? The major difference is how you import and export files. Okay, how you import and export files. That's the major difference. So let me just briefly show us a demonstration here. Okay, um, let me create a folder. I will call it modules demo. I think I would like to, let me just close it, and let me close that so that it won't confuse. Let me close this workspace here and open only this one. Okay, now let's take this example. All right, so let me define something. Let me define a mass.js. By default, this is CJS. It's common JS. All right, Node.js would see it as CJS. Now I want to define functions like add. Sorry. All right. Okay. Hello, guys. Hope you can see my screen. Thumbs up if you can see my screen, please, so that I will start my explanation. Thumbs up if you can see my screen. My screen. Good. Good. So now I have defined these two functions in this my module. Now I want to export in common JS. This is how I will export it. I will do module dot exports. Now I want to export these two functions. All right, I want to export the two of them. I will do equal to put. You know what this thing is object. I'm initializing object. So this module here is a global property in call it global object in Node.js. It has a property of exports. So if you want to export functions or any property, any member from one file, so that it can be imported into another file, into another module or file to be used, you have to use in common JS. You have to use this format module.export. Then I will now do add, then sub. So basically what I'm saying is that I want to, this is the name of the function. This one, okay, let me not confuse you guys. Add, let me do this. So now I'm exporting this add as add exports. I'm exporting sub, this sub function as sub exports. All right. Now, how do I import it in another file? Let me create another file in another module. Let me create calculate.js. All right. Now, if I want to import it, this is what I'll do. Const. All right. Hold on, let me finish this sub. I'm going to use the require keyword, then the 5 parts of math. You can see it, right? These two names, because I exported it as objects, all right. I exported the two functions as objects. Now when I'm importing it, I will import them as this is the structuring, all right, like we discussed in our JavaScript class. I will structure it this way. Then the file path must be correct. This file path must be correct. Okay. Then I can now use it. Let's use the add 7, 6 and 7. Let's console log and see what it will give us. My terminal spin up. Wait for it to spin up. Alright, yes. So if I do node calc and run, you see it gives 13, right? It means this function ran. It added the two of them. Okay. If I do subtraction, minus 5 from 25. If I run my code again, you're going to see, oh sorry, I want to do the subtraction part. Minus 5 from 25, we're going to see 20. So you see, I am able to use the functions I exported from here to here, right? Now I can, let me, what if I rename this now like I did it before? I rename it to add, and I rename this sub to sub. I can give them any name as I want, as I feel like. All right. But this name here, this one here, this one must be the name of this. Then this one must be the name of this. All right. Now, since this I've made them the same name, the two names are the same. Add and add, sub and sub in JavaScript. Since the two names I've decided to use the same name for them, I can just remove any one of them in JavaScript. Even in Typescript, it is allowed. I can remove it, do it this way. So if I do it like this, then it means if I come here, these names are no longer are not the same, are not what I'm exporting again. So as you can guess, right, I'll change the names to this. Even the editor will tell you, will notify you that something is wrong. So I'll change the name of my functions. All right, if I run it, to still run. Okay, so this is common JS using require. This is require. You use require to import, all right, and you use this module.export to export. That is no JS, that is common JS. The two things there is using require to import, like using a module.export to export, and using require to import. Okay, what if I want to, guys, hold on, let me, okay, what if I want to export only this function, div function? I can do this. I can export. You can export one entity this way. Just put it directly on the export. You can do it this way. Then if you do it this way, when you are importing, all right, when you want to import it, you don't need to put this bracket again. This you don't need to destructure it, because you're importing one entity. You do it this way. You can give it any name, then require. You can give this any name. You can call it any name. You can call it the name you give it. All right. Since you are not destructuring it, so the name does not matter. Okay, you can use it. So if I call the function 8 by, if I give it 8 and 2 is division. If I, sorry, okay, let's run the function. You see it's 4. It gives me 4 because 8 divided by 2 is 4. So this is how you import and export from CommonJS. All right. Now let's talk about the EJS, the ESM. I mean, sorry. If I, let's write the same function, but this time I will do this. I'll give it .mjs because I don't want to initialize this thing. Then still, now if I take the same functions, guys, hope you are following. If I take the same function, now these are the same function. How do I export? Now there's what they call named exports. These are named exports. Okay, named exports. These two, add and subtract, are named exports. So if you want to import named exports in, if you want to import named export in your ES module, you're going to destructure it. Now this is how we import in ES module. As you can see, it's already detecting it. Use imports, to structure the item you want to import from the part of the file. So we are using two keywords: import from. All right. Then the structure, the next one is sub. All right. So with this, I'll be able to use my function. So let's call calc again. So you see it works. 5 minus 20, 25 minus 5 is 20. Okay, same thing, add will work. So that's name. We did named exports, that we destructure it. So there's another one called default exports. Default export is, if you do export defaults, export default. See, I did named export for add and subtraction. Now I'm doing export default for div. So how do I import it in another module? So because these two are named exports, they need to be destructured. Okay, but for the div that is default exports directly, I don't need to destructure it. Okay, and I can call it any name I want. This is anything default. So, and you can only export one default. Like here I have two named export, like normal exports, named export. I have two of them. I can have as many as I want. But in a module, near ES module, you must have only one default export. If I try to, let's say I try to do sub a default export. As you can see, it's already complaining. See, I can't have double default exports. A module cannot have multiple default exports. Okay, so that is that. You can have multiple default exports, or you can have multiple named exports in ES module. This is ES module right now. All right. So basically, those are the two exports. So in TypeScript, in normal Node.js, you can use you can use CommonJS and do your thing, or you can use ES module to do your thing. But in TypeScript is just ES module. All right. We'll be using more of these exports and imports from. Okay, we won't be doing require this one. We won't be doing this one. Okay, except we want to use normal JavaScript. All right, so that is modules. Okay, guys. Then the next topic I want us to look at is the modules, the what's it called? Okay, no, let's look at npm node package manager. Your introduction. Okay, npm is the name is node package manager. npm node package manager. npm is the standard package manager for node.js. All right, a standard package manager. It has packages registry, where if you write a package that you want other people to use, if you write something, a code you want other people to use, you deploy it to the registry, to the npm registry, and people will I mean JavaScript ecosystem, of course, people will import your packages and use, just like the TypeScript now that we want to demonstrate on, because we need to install TypeScript as an npm package and use it. It's a package that was written and exported and people use. So let's go to the registry. If you go to npm, npmjs.com is the landing page of the registry, npm registry. So this registry holds a lot of packages, like millions, like you saw in that. It's like about 1 or something million. Any package you're going to be looking for is here. You yourself, you can build a package and deploy, and and bring it here. People will import it. All right, people will import and use your package. Okay, so if you just search for a package, if you deploy your package, they will give your package a page, just like here in TypeScript. This is the package. This is TypeScript package, versions, dependencies. This is how you install it. npm install, you install it. This is their home page. This is their GitHub repository. Let's look for Express.js. Express is here also. This is how you install Express. All right, npm I stands for install. We're going to look at all those things. Then when you install, you're going to get package.json, package.json. Right. This is Nest. Let's look for Nest.js. This is Nest.js. So these are the two. Our project is going to be on Express.js and Nest.js. So this is Nest.js. Why is that this thing? Why is that page empty like this? Okay, so okay. All right, so guys, let's start something now. Um, so you are now we're going to initialize an npm package. Then I'll show you the structure of the package. Then we'll start our proper demo. Okay, so we're going to discuss. I wanted to discuss I wanted to discuss modules, Node.js modules. I want to use a JavaScript, but I don't want to do that. Let's go directly and use TypeScript for it. So because of that, I'm going to start an npm project. Then you see how that is done. So let me see. Okay, okay. So let's come here. Let me use directory. Guys, this is time to, if you want to, you need to start coding along now. Let's start. This is what I'm going to do. I'm going to initialize an npm package. I will install TypeScript for us to be able to run our TypeScript code, right? So this is what we're going to do now. So I have created a new project. Please open a new project in your IDE. So do as I do now. Um, so to initialize an npm package, if you have Node installed, to check if you have Node installed, automatically it comes with npm, so you don't need to install npm separately. So I have Node installed. If I check my Node version, My new version is 20.19.4. All right, so it's automatically I have npm installed. So if I do npm iv hyphen v, so my npm's version is 10.8.2. So I have npm installed. So if I want to initialize, this npm package project in this my folder. I will just do npm init. All right, now if I do this npm init, it's going to give me, like, it's going to, I'll see some prompts, the name of your, what to do. You just see the prompts here. So, but if I don't want to follow, if I don't want to follow the prompts, if I just do hyphen y, no, I mean space hyphen y, it won't give me all those prompts. It will just create the file package or JSON file for me directly and input the default values for each of the properties. You're going to see it in a minute now. But if I want to follow the prompt, I will just remove the hyphen y. Hyphen y is just like, it's the same as that, just yes. That's, it's telling the initializer that use all defaults, everything as default. Okay, so let me just remove it so that you guys will see how it goes. So if I click enter, okay, if I click enter, all right, so yes, the first thing was my package name. All right, what's my package name? I can just say node node demo. All right, if I'll click enter, version can do 0.0.1 if I want. Description, a demonstration on NodeJS modules. If I click enter, entry point, okay, yeah, I'll go with your default value. Click enter. Test command, default. Registry, no, I don't want. Keywords, no, nothing. Author, I'll just put my name. License, use any license. Now it's not telling me this is what it's going to create for me. I'm all okay with it. This is what it's going to create for me. The answers I gave it and the default answer it's allow it to use. Then if I click yes, yes, look, as you can see, this has been created for me. Package.json. So this is the almighty organizer. All right, this thing here, this is your project. Okay, so this is the root of your project, the root folder of your project. Anywhere this package.json file is the root directory of your project. So with this now we can start proper demonstration, installing packages that we're going to use, and yeah, basically, yeah, installing packages we're going to use and do whatever I want to do. Okay, so all right, so first things first, let's install TypeScript. So to install TypeScript, guys, please initialize this project. Do this, please do this. So to initialize, if we go to our registry, go to the home folder and type TypeScript. Okay, if we come here, this is the command to run. But one thing about this command is that there are two kind of commands. There are two types of commands. All right, we have the, let me just create something first. This, oh, hold on, let me leave it. We have the command to create to, we have two dependencies actually. When you are working on a project, you have two dependencies. All right, dependencies are the packages that you need for your work, like things like package type is a dependency. All right, Express, when you install Express, is a dependency also. right? They will come into your project as dependency. So npm manages dependencies in two ways, right? Basically, general in general view, two ways. There's dev dependency, that's development dependency, and there's normal dependency, or you can call it production dependencies. Now, what is the difference? Production dependency or normal dependency is the dependence that when after you've finished your work, it's part of your project. You are using it to build your project, like it's part of your project. So when you deploy your project, it goes with it. Okay, like if you have a maths, if you install a mathematics package that you use to do do mathematics in your project, maybe you are adding money, your business logic, you're adding money, and the rest. You when you are deploying your project, you deploy it with the package because you need it to to run your business logic. All right, so that is normal dependency, or you can call it production dependencies. All right, then there's development dependency. Dependencies, those are dependencies or packages that you don't need them in production. You actually just use them to to run your code as you are developing. As you are building your as you are developing, you just need it to run your code. All right, so when you are deploying your project, you don't actually need them in production. Your code does not need them to run your production. Example is TypeScript that we're going to install. TypeScript is just for development. When you finish building your TypeScript project, all right, in your system, if you are deploying it on server, you are not deploying TypeScript. No, servers don't run TypeScript. They run Node.js. They run JavaScript um, project files. So when you finish building your TypeScript project, to deploy it, you will build it. There's what they call building process. You have to compile the TypeScript, all the TypeScript files to JavaScript. So it's the JavaScript that you will deploy to your server. Okay, so because of that, when you are installing TypeScript, because you don't need TypeScript in server, so you don't install it as a production dependency, you install it as a dev dependency, because at the end of the day, you don't want to export, you don't want TypeScript to be installed in your server when you host your backend. Okay, so that's the two things. Also, some other dependencies we're going to see are just for development use. Okay, but Express, when you install Express package, Express is the main server you're building now, is what is creating your REST API. So you is a production dependency, and you need to export, is need to, in fact, it's your server. All right, so that is that. So with that now, if I want to install a normal production dependency, I can do this package name. This is how you install it. Npm install hyphen hyphen save, or you can just omit, can just hyphen hyphen save and the package name, or you can just omit the hyphen hyphen save and leave it like that. It will install a normal dependency or production dependency. All right, but if you want to install, dependency development dev dependency or development dependency, you use hyphen hyphen save hyphen dev to do that. All right, you must use it so that it will install in the dev part of the dependencies. Or if you don't want to use too much, you can just do hyphen b capital D, npm install hyphen capital D. These two commands will do the same thing for you. All right, so when you do this, it will install in your dev dependency. So as we want to install TypeScript, we're going to use one of these commands to install TypeScript. And you can also this install word here, you can just use npm I, is the same thing. All right, and when you don't specify, okay, when you don't specify a package name, when you do npm I means that you want to install everything, all packages in your package.json. So basically, just what we're going to do now. So let me explain what these items here in package.json. This name here, as you know, is name what you decided to name your package. And as you're building that project that we want to install, the name is not too important now. But if we are building a package, when we want to create a package, you want to create a package that you want to install in that, you want to upload to that npm registry, you want to install, you want to upload to this place. All right, if you're building a package that you want to bring to this npm registry, this name here is very will be very important, all right, because it must be unique. It must not have the same name with a registry, a package that is already in the registry. So you must make it unique. And one of the ways that people make it unique is that you can just use something like, if I want to do for myself, I can just do something like this. I put I do this, I give it use this art sign, give it a name that is unique to me, then give it the name I want. Even if there's a package already that has node demo in the registry, because of this thing I did here, the name will be unique and it will be accepted in the npm registry. Okay, so that's that. Then the version is any version you put there. So this version is what you'll be seeing on this part. Like if we go back to that TypeScript, go back to this TypeScript page. Yeah, this is the its versions. All right. So these numbers here you put here, these numbers you see here are the numbers, are this are what reflects there. So if I push this thing now, if I wrap up this project as a package and push it to the registry, you will see this version here. When you come here, you see the name and you see the number there. All right. So that's the package. Then description is just description. Then there's you can put your GitHub you can put some information here that will reflect here. All right, that reflects here and here. Okay, you put them in the packages some. Then script is for my development. So if I want to initialize start my project, I'll put the script. We're going to do that. We're going to see that very soon. Then author is name of the creator of the package. Then license is the license you want to give out. Is it a public is it an open source license project? So basically this is just the whole thing there. But when we install, you start seeing some things in this package. So that being said, let's install our first package, and our first package is going to be TypeScript. So guys, type with me npm hi I'm using the shortcut I told you guys. So I'm going to this is it. So it's going to install TypeScript in dev dependency. You're going to see a folder here, node modules. You're going to see node underscore modules here as a folder when this TypeScript is finished installing. So let's go. Let's see if my network is fast. So it's creating, installing. As you can see, node modules is already here. So this node modules folder or directory is where all code that works with TypeScript is going to be installed. Any package you install, the code is going to be here. Now it has generated another package JSON, another package -lock JSON. This file here is important. All right, it keeps track of the versions of the different dependencies you are installing, and the pair dependencies too. Like here now, okay, let's see. Okay, guys, take a look. This is dev dependency. As you can see, it's now installed. TypeScript is now installed as a dev dependency in this project. Okay, that's what I told you about. So this is the dev dependency. All right, so it's installed, and the version is this is the version. So the difference between this one and this one, this you don't edit this. You can't come and edit here. You can come and edit something here, but this is not advisable to. You don't even need to edit anything. So this is where it keeps track. Package node npm keeps track of the specific versions of your dependencies and the rest, and some other things that are it's not too, it's complex for now. Let's leave them, they're not too important. So I've installed npm. So now I installed this thing. So I've installed TypeScript. So I need to initialize TypeScript. I need to make this project a TypeScript project. Like it is now, I've installed TypeScript, but it's not a TypeScript project. Okay, I need to make this a TypeScript project. And how do I do that? I need to do something. I need to initialize TypeScript. And how do I do that? I will just initialize it with this command. TypeScript has this command npx. Npx is also like npm, but it's kind of, I'll explain later. Npx tsc. Tsc is what is the binary that you install with TypeScript. Because I installed TypeScript, I have access to TSC. TSC is TypeScript compiler. I have access to TSC. Alright, if I didn't install TypeScript, I will not have access to TSC. Then I'll do hyphen hyphen init. This is the command to initialize TypeScript. If I type this command in my terminal, it's going to initialize TypeScript project for me here. So now npx is kind of npm, but it is used to run TypeScript packages that are within your inside your project. Okay, let's say for example now I have TypeScript. I can install now. There's kind of a package. You can install a package globally on your system, or you can install it only inside your project. I don't know if you understand. Like if this TypeScript now that I just installed inside my project, I can decide to install TypeScript globally, like inside my system, so that any project I want to do, I don't need to be installing like bringing installing TypeScript again. I'll just install it once and for all in my machine. Any project I want to do, I'll just be using that TypeScript that I installed inside my machine to be initializing TypeScript or any project. If I create any folder anywhere, I'll just use that TypeScript and initialize it. But it is not advisable to do that because versions of TypeScript may change, and because of those version changes, it's not good to install packages globally. All right, just install in your project and use. So now TSC we differentiate it's npx, sorry, npx we differentiate. If I have package, let's assume that I have TypeScript. I've installed TypeScript before globally in my laptop, and I came to this project and I forgot that I've installed TypeScript globally, and I came to this project and I installed another TypeScript here. Now if I didn't use this npx, right? If I didn't use this npx and I type npx, I type just tsc hyphen init here, because I have TypeScript globally, this tsc will be the global one that I install in my laptop. It won't be this one that I installed in my package in my project. Okay, but because if I now use npx, what npx is saying is that use the one that is inside my project, not the one that is globally. So npx is like telling the command that go to the package that I install inside this project and look for the whatever you're trying to use, the binary you're trying to use inside your project. I don't know if what I'm saying makes sense. So that's why I'm using npx. So let's go, guys. I want to initialize now. Let's watch nps tsc init. So bam, this is it. This is a new file, tsconfig.json. This is TypeScript. This is what defines your TypeScript. All right, any project that you see tsconfig.json is a TypeScript project. Let me remove this thing here. ts is TypeScript already, then config is configuration. So we have it. There's no package installed, nothing was installed, just initialize. Then this is where we now config our project so that TypeScript compiler can now compile our project very well, and the typings will be okay. So if you did this is what I needed to do. This is what I needed to do. First, come here, come to your project, to the root of project, create a folder called src. All right, src is where your ts files, everything you're going to write about your project, all the codes are going to live inside here. All right, tsc. Now in a generic TypeScript project, you have two folders, two basic folders that are like globally, just like I have this src. There's src and there's dst. I mean dist, sorry, dist. Or you can, if you don't want to use dist, you can use build folder. All right, why we have those two folders is this: src will contain the TypeScript code of your project. Then when you want to deploy and build your TypeScript project to JavaScript, they are going to be those JavaScript code that you compile to will now be in your dist folder. All right, so we now have two folders, two codes, two directories containing codes of your application in your project: the tsc, which is in src, and the the JavaScript which is in the dist, and it is that dist code directory you are going to deploy when you are deploying. You are not going to deploy the src one that contains your TypeScript. I hope I'm making sense, guys. Let me check if I'm still connected. Sorry. Please give me thumbs up.
Yes, you're connected.
Okay, you can see my screen, right?
Yes, I can see it.
Okay, okay. Please, if you are not seeing my screen, let me know. Let me so I can check. So, guys, this is it. We've started. So now I have TypeScript enabled. So we have to do a couple of things. First, now we have initialized TypeScript. Now this is what we're going to do. We're going to install two other packages. All right, we're going to install two other packages. We're going to install this. Um, I'm going to install this. Now this is just this we're going to install this. This Node.js, since we are coding a Node.js environment, even though it's TypeScript. All right, most of the things that are peculiar to Node.js, their types are not specified in they are not specified in TypeScript. So if you install this, as you can see, this at types forward slash node is going to install some typings, like some types in your TypeScript project, so that when you are when you are calling some core Node.js Node.js modules, the JavaScript TypeScript will not complain about types, that you can't find types, because any package you install inside the TypeScript, when you are using their functions and their variables, TypeScript will be looking for the types of that, like the types that those functions are returning or taking. It will be checking them, and that's for projects that are not written in JavaScript, in TypeScript. Some projects are not written in TypeScript, somehow in JavaScript, just like Express. Express came along before the TypeScript was introduced. So all their code is in JavaScript. So we need to install this. How do we install it? Because you can see the command is already there, but it's a type. Is a typing dependency. Is a type. So we don't need. We are not going to install it as a production dependency. It's going to be in dev as a dev dependency. Okay, because we just for TypeScript to function well. It's not for. It doesn't make our app to behave like we're supposed to behave. So we're going to install it with npm I in dev dependency. That's what it means. Then the name types node. Now I can install multiple. I can put another package here, put another one here at a go. All right, so and that's what we're going to do. We're going to install another. Okay, no, let's leave it first. Let's leave. There's something I wanted to install, but so let's install this. If we go to our package JSON, still installing. It has installed. So guys, you can see it. So this is the version and this is the name of the package. So it is installed. So what do we do next now? All right, come to your ts config. We need to specify something here. So we need to tell TypeScript where to look for files to be compiling and to be type checking. All right, as it is now, TypeScript doesn't know where to look for. It will just be looking randomly in our package, in our project. So we need to tell it that you need to check only this directory. All right, how do we do that? Just come here, include include property takes an array of strings. And what would that array be? Sorry. Okay, I'll usually like to do this way, but I'll say look our inside our src for directory, then everything and subfolders too, then anything TypeScript extension. That's what you are going to be compiling. All right, that's what we've told TypeScript as it is now. So it's going to be looking into this our src directory. Then the exclude, we need to tell it don't compile, don't go and be checking this folder, it's not needed, it's not part of our project, it's not part of our code, written code, is could be something else but not part of our written code, so we don't need you to be type checking it. All right, so what is that, what is that folder? This node underscore modules is where our packages that we install stays. So we don't need TypeScript to going into there to be checking if anything is if you are, if anything is not compiling or something. So we need to exclude it. So to do that, you use exclude keyword, and it takes an array also. So you just do node underscore modules. Then now look at this place. You can see root directory, and you see src here. I'll comment it because we want to tell TypeScript that this src is our root directory for TypeScript to check. Okay, now this, you can see out dire- out directory. I'll comment it. So we're telling TypeScript that if when we compile our project, put it inside a dist directory. Hope you guys can see my.
I have a question, Christian.
All right. Okay, go ahead. I'm listening.
Okay. So my question is, in the command that you wrote for include,
Yeah,
you
yeah,
wrote include the source directory, then double asterisk,
yeah.
and any TypeScript file there. So my
Yes,
question is, um, with respect to nesting. So what if you have a TypeScript file directly under source? Will this command capture it? And
yes.
then what if you have some other TypeScript file deeply nested, maybe like 4 5 levels of folders? Basically, will this command still capture it as well?
Absolutely. It will capture everything.
Oh, okay, all right. That was my question.
Yeah, to capture everything.
Thank you.
If I you said you tried installing but you're getting an error, could you explain what kind of error you're getting?
Basically, I joined the class late. I think after having like I don't understand a single thing.
Okay, okay, no problem. But you can. Well, though I'm recording, so at the end of the day, you can take the recording and look through. But
Okay, sir.
let me just flow so that those who are following won't feel. All right, guys. Um, so then next thing that we'll do here is to come to these types here. That is empty array. Just because we installed this node here, types node. All right, we'll come here and say type node. All right, guys, take note of these steps that I'm taking. It's even here. It's even if I remove this here and uncomment this. Okay, this you can uncomment this, then you are good. Then um there's something I want to, this thing here, do this, make this false, this verbatim module syntax, make it false. Then there's one last thing. Okay, I'm just taking it one after the other, like carefully, so that you guys will not miss whatever I'm trying to demonstrate here. Yes, that's okay. Something I'm looking for, inter. There's something I want to add. I don't know if I'll be able to get the name. Inter up. Oh, I've forgotten. Let me let me Google the name. I will tell you guys what's. Let me confirm if that's the right name. Interoperability. Module inter. Yeah. Set it to true. The reason why. Yeah, this is it here. The reason why I like setting this to true is because some package that you will install may be written in JavaScript. Okay, so if you set this to false, those packages you won't be able to use them. TypeScript will throw an error on on the project. But if you set this to true, you'll be able to use those packages in your project. So guys, this is my setup that I want to do. So let's do our coding. All right. So the first thing I want to talk about is is node async.ts. Now, what is node async? Just like we discussed in our class before, we talked about the synchronous how JavaScript executes async transactions. Like if it's there's there are transactions that blocks the single thread, no just is single threaded. All right. If you give it a transaction that's supposed to block the thread, there is a way for you to like make it asynchronous in the sense that instead of that transaction to block the thread, when you give it if you call it in that manner, either the promise or callback or a callback feature of the JavaScript is asynchronous nature. If you give it, so instead of running, blocking the thread, JavaScript thread, it will take it the event loop, like it will take it and execute it in the background via the event loop and activities and the rest. So then it will return a promise. So a promise is like is a value that is being promised, and it will the value will return when that transaction has been executed. So I demonstrated some things like I wrote some code that's supposed to run from top to bottom, and some of them did not run. Some at the top did not execute until later. All right, so that is let's just do a brief demonstration on that now. That's what I want to demonstrate now. So if I do something like, okay, now one of the asynchronous processes in Node.js is, Node.js have some modules. We have the FS module, the file system module. We have the HTTP module. That's HTTP is the core thing that we're going to be looking at. We have the event module. We have the OS module. These are the things we're going to be discussing. Let me go to their. Okay. This is it. We have the path module also. First, the path. Let's look at the path. The path is where you you import it. You use it to like get path to your directories in your project. Okay, independent of the OS, the operating system you're using. So we're going to see this in demonstration. We're going to do a brief demo on that. That's the path module. As you can see, this servers. Then we have the event module. We're going to demonstrate the event module. Okay, the event module. There's a lot of events attached to that. Then we're going to look at HTTP is our main guy. HTTP module. Okay, we're going to see how it's done, it's used. Then FS module, file system. We're going to do so file system, some IO operations, input output, like writing to a file, reading from a file. Some network operations are they are executed in promises, like they are executed in promises because they are in async manner. So when those Node.js see those those methods are being called, it put them in queue. It put them in queue, the micro micro task queue or the macro task queue. All right, then it executes. Okay, so let's do a demo on that so that you guys will understand what I'm trying to say very well. uh okay, thought I use this thing instead. Sorry guys, let me confirm this. Okay, so I'll do two demonstrations here. um Macro tax. Okay, set timeout. Just set timeout. Let's put it zero, times zero. Then let's do promise. We've seen this. We've seen this before. So I just want to tell us, show us the synchronous nature of Node.js. Is promise. Okay, so function. Let's do our normal add function. Now type number, type number returned. If I call add of, then if I console log just simple string. Okay guys, look, let's have a look. Now you see JavaScript and Node.js run from top to bottom. All right, top to bottom, left, from left to right. So if you look at this function calls now, here I'm calling the set timeout function. Here I'm calling the promise resolve function. Here I define the function and I called it here. Yeah, in this place I'm also calling a log function, or I'm logging something. So in hierarchy, how do you think this code is going to execute? Now if I explain, um, if I run this code now, how do I run this code? Now let's install another package guys. Now this is a TypeScript file. I can't run it like this. I can't do something like this. I can't run TypeScript like this file with, sorry, it's inside RC. Currently with Node.js, if I do that, you see it throws an error. So Node.js doesn't, Node.js does not understand TypeScript like that. Okay, so I need to install something, a package that will help me to run my Node files. Right. So please, if you have a question, speak. Just unmute and speak so I can hear you. As I'm typing, I won't be able to see your questions when you type it in this box. Okay. The verbatim module syntax, what it means is that um, when you write your code, sometimes TypeScript will want to like convert your code to something like the way you wrote it. It converts it or to something. Like if you use require it, you want to use convert it to imports. So verbatim says no, leave it as it is. don't do that transforming. Okay, so verbatim module is telling the compiler leave it as it is. So guys, let's install this package. Let's go to the registry again once more. Let me see. Okay, ts node. So this package ts-node-dev. There's ts-node alone, but I like to use ts-node-dev. Okay, all right. So let's install it as a dependency package, not as a production package, normal dependency. Let's install it as dependency package, and we'll use it to run our TypeScript. So let's come back here. Normal command npm I hyphen d, then the name of the package. This is it. If I install it, wait for it to install. So what this package will do is that it will wash as I'm writing. It will be washing my file. If I make any changes, it will run the code. All right. So to do that, I'll give it a command. I'll put a command here. I'll give it dev, the name, and I put specify the kind of commands that it's going to execute. So this script is where you put your commands to execute on your project. Okay, as you can see, this is a test command. If you want to run tests on your scripts on your project, then here I will do this npx. Remember npx, I'm telling it look for the package, whatever I'm trying to run here. The binary is inside the project npx ts, then I'll call the name the of this package. Then I'll have to give it a name, the name of the file to execute whenever there changes on the project. src node hyphen async.ts. Okay, if I create another example that I want to work on, I'll come here and change the name of the file after I'm done with this node async demonstration. Okay, having a depend okay. I'll have to install this again. Okay, so guys, let's execute our code. If I do npm now to run this script, to run this dev here, this dev command that I give all this command, I'll just do npm run. I must put run, npm run, then the name of the command, which is dev dev. If I click enter, it's going to execute that TypeScript file. Then it will be in wash mode. Okay, that it has started. See, it has executed those things. Okay, so now let's have a look. We first call this timeout, set timeouts here. It's supposed to run first. If now normally conditionally it's supposed to run first, because it came first. This is supposed to run second because it came second. Why this, we run, you know subsequently. But that did not happen. First, the addition came, ran, which is why we got 17. Then this one next. All right. So what that's then this one promise the promise one and the set timer task. What that is telling us is that when we executed these things, um, Node.js queued this function. It did not execute it. It queued it. Put it in queue because of its set timeout. So any logic we put inside this set timeout, any logic we put here, we just put console log. All right, but any logic we put here, which could be a heavy, probably a logic to read a file or to write a file or to call an endpoint. All right, any logic we put here will not be executed instantly. It will be queued because it will be put in the queue so that it will not block our thread. All right, then the same thing also, this there are some processes that will be a promise, that will return promises. All right, that return promise. Then node will not execute it in the thread immediately to put in the queue. Then go further to execute every synchronous task. Now this one is synchronous. All right, to just execute, doesn't block the thread. You just add and console log and do everything. Then this one followed next. That's why we got this and this. Then later, when this promise is returned, when the promise, like when our this function later executes and the thread, a single thread is now the stack is empty, this one will now execute. Then later this one will come forth. So we're going to get the hang of it when we start doing proper API calls and the rest. So that's for async, guys. Let's go to the next one. Yes, let's do FS. All right, guys, spin up node. We're going to look at FS and path together. So guys, if I do, let's use the FS model. So we can import FS like this. Any node module this way. Any module that is peculiar native to node, or we can do it this way. All right. This will tell Node.js that okay, it's particularly a module from Node, not a install package. Okay. So if we do, let's import the path module. So we want to write to a file. We're going to create a file and read from that file. Okay. So let's create this folder called data here. So let's write something inside that folder. Now, how do we need to get the path to that folder. Oh, it's 4 already, guys. Okay, let's just quickly. Okay. Okay, guys. Okay, let me finish before fs dots. Okay, guys. Please look at this. Look at what I just wrote now. I'm using two modules, two Node.js module. I'm using the file system module and the path module of Node.js. Now, this is what I did. I want to create I want to create a file that is called example.txt. All right. Hold on. Hope I'm not disconnected. Guys, give me thumbs up if you can see my screen or you can hear me. Sometimes I feel my network will...
Yes, we can.
Okay, thank you. Okay, so I am trying to create a file that is called example.txt, and I want to write this value into this file. Now, what does all this thing mean? This path.join is telling what it's doing is that it's taking this this is underscore double underscore and dir name. This is a global Node.js property. Okay, the global Node.js property that it takes the absolute path of the directory. Okay, of your of the directory of the project. Okay, so here now it takes the absolute path, then it will join it to the data directory that I just created here. That's why I created this data directory. Join it. Then the last part here is this the file example here. So if I console log this file path, let's see what it gives us. Let's do that before we write. Let's change this one will now be node fs path. So if I run dev, let me run dev. It hasn't console logged yet. It's just starting. Yeah, this is the path here. This is what it console logged. As you can see, this from this place, from this data before data down to the left here is this double underscore directory name. Okay, so then it concatenates this data for directory with this file extension. So whatever we're going to write is going to be stored inside the file extension. Okay, so and what are we writing now? This is what we're writing. We're going to create a file and input this data into it. This is the module, the method that helps us to create a file. Right, so that's one of the utilities of Node.js. So if I run this command again, we're going to see the file created here. You still execute. You see in the in data folder there's no file, but when it finished running, you're going to see the file. Yeah, this is it. It has been created inside it. Then inside it you see hello node. Okay, this is how we use Node.js to create files. Okay, then we can also go ahead to read. Because of time, guys, let's just skip this one and go to the next module. I want us to get to let's look at events. Let's look at the event module, guys. Where's my event? Okay, so
Sorry, can you hear me?
yeah.
Okay, please, I wanted to ask on this console, the terminal basically, there's this info in brackets. I just wanted to ask, where is it coming from?
Okay, this package that is running this one, this ts node dev. That's what is causing. That's what
Oh,
is
okay.
yeah is responsible for it. It's not actually part of. It's just
Oh,
informing us that it's running.
okay, okay. Thank you.
You're welcome. Okay, so let's import event emitter. Event emitter, not from stream. Event. So hope you guys know that event JavaScript is event driven event driven language, like you can, this is it on, if a JavaScript is event driven language, and this is what it means. Okay, so guys, I've used this is the events module. I am getting the event class, the event emitter class from it. I have initialized the event emitter. I have created an event on the event emitter. So what this means is that when you're writing your Java, when you're using Node, you can use the events to do a lot of things. Like if you can create, you can, your API, when you create an API and API that receive request, you can say, okay, in this API, after you've done some processing, like when they call the API, they do some, the API does some processing. You can plug in some events on that say, okay, on when this event is this, when this request actually did this thing, let this event run. Okay, the event will just execute in the background. It will not be part of, when you send a request will go with response. If you send request, it will go with response. Just as we have been, if you go on browser and you type something, or you try to log in to Facebook, for example, when you log in, Facebook will send request to their server. The front end will send request to the server, and the server will give a response. Okay, if no response, it will hang and the network will break. Okay, so when you send event requests, there will be a response, and the time, the latency of that request response matters a lot. It tells the responsiveness of the server and the client. All right, so there are some tags that you don't want the request to wait for response, to wait to the server, like the request to wait for, before the response with the task will finish and you get this client will get the response. There are some tasks that you just want them to, as the request has come in, they should run in the background. The request should not wait for them to get a response. The request should just come, enter, the process will just start running in the background, then you send a response back to them. So this event emitter will do for you. You can write a function in the background that when this request comes, it will emit an event. The event will start running in the background, then the response will go back immediately. You understand? So that your server will be efficient. Okay, so that's what basically what this event emitter does. So I have created this emitter. This is basically how you do it, but it will now, when you're building your project with it will now depend on how you structure it, what you want to do. So it will do a lot, but this is the fundamental, the how you emit, and you create and you emit. So if I want to emit this on this grid event, I'll just do emit. I'll do something like, just say John. So if I run this code, which is node event. So yeah, so we created an event and we emitted that event. So it's this function ran. After we finished creating the event we did not run, but when we came down here and emitted, like we emit the event and gave it this name, that's how we're able to see this John Doe. If we do not emit it, nothing will run until we emit the event. All right, so this is for event. Okay, then the next one is operating system. Let's just have a look how the operating system works. The operating system module. So if you want to do something with operating system, um, The next one after this will be our HTTP module. So this will tell you some things about the operating system. Okay, if you want to know our operating system type, I'll do something like os dot. All these are in the documentations, guys. If you want to check the platform, wow, taking time. If you want to check the architecture, it's okay. Let's see how many CPUs we want here. Let's see how many CPU you have here and the length. Okay, let's just leave it here. If we do change it around, guys, if you have any question, please feel free to ask again. That's why that we are behind time now. Okay, it's going to console log all everything about. Yeah, as you can see, yes, operating system type is Windows, and the platform is Win22. Architecture is 64 bits. Um, okay, CPU count is 4. So guys, that is that for OS. So you can do a lot with Node.js, guys. You can do a lot with Node.js. So the next one now, guys, is our HTTP. All right, guys, let's do this. Let's create our server. This is what we use to create our backend. All right. Okay. HTTP. Let me do this first from, so you know we are node HTTP incoming message server response. As you can see, there's auto complete consts. Guys, this is it, the moment we've been waiting for. Create server. We are creating our server now. Now this server will take a function. It's an higher order method function. Takes a function. Let me create the function here. I don't want to create the function inside it so that it will not look confusing. So let me call this request handler, the function that will handle our requests. So if we want to write a function that we'll put here, this is how we're going to put the function. We're going to put it here. If we write a function that we're going to give to our create server, to what create server we do with this function is that when it creates the server, any request that the server receives is going to run this request handler that we gave it to run. So any request, when we create the server, any request that comes in, it will execute this request handler on the request. Okay, that's why I named it request handler. So it's supposed to take two arguments, request and response. Okay, takes two, request and response. So I need to type it. I need to give it a type. Give this one incoming message. Type it because TypeScript is not happy with that if you don't type it. Server response. Okay, the incoming message is the request that is coming, the message that is coming, the request that is coming. The server response, the response is the server response that the server will send out. So what do we need to do? What do we have to do? Should we do? Let's do this. Let's just respond to the let's just respond to the server. To respond, we just write to this. Let's give it okay, that we are okay, this request is fine, it went well. And the content type will be application JSON. This is the most popular. Then at the end of the thing, let's end our request with a message. End the response with a message. Hello from Node. Okay. Now we have created our server, guys. This is now our server. Now servers need to run in a port. Servers run in a port. Okay. So let me create this port constant here, 5000. When you create a server on your system, they need a port to run because this is a network item. So our server now will say listing. All right, we need to tell it where to listing, the port to listing. We're giving it ports, then we'll give it a function to run. Let me use arrow function here, a function to execute this function, or I can just come here, function to run when the server starts. So just say server running on ports. So I'll now put this list function here. So guys, this is our server, our Node.js server. This is how the fundamental. So let's run it. We come here, http h. So guys, let's execute. So it's coming up, it's coming up. We're going to see the message. This message, when it comes, it means that our server is now listening. Yes guys, this is it. Server running on port 5000. Now we have a server running. So any request we send to this server is going to return this message, hello from node server, to us. So how do we send a request? Let's open our node, let's open our postman. I'm going to create a, if you're not familiar how to create how about this postman, this is how we do that. You work with it. So if you just open your postman, you create a workspace. There's a way you come, you log in first, you sign up, or there's a way you sign up, you log in, then you create a workspace. In your workspace, you will now create a collection. Okay, you, when you come in, you sign up. When you sign up, you log in. After logging in, you create a workspace here. You see options to do that. When you create a workspace, then in your workspace you now create a collection. A collection is like for this if we start building our project, if we start working on our project, I'm going to create a collection. So that collection will handle different endpoints, endpoint to get to create user, to authenticate, to create a post. So different folders that will be in that collection, and each of those folders will be handling, will be responsible for each of the endpoints. So let me just create a simple collection here. To do that, you click new. You look for, if you want to create workspace, you click workspace, but I don't want to click create a workspace. I want to create a collection. You can also create other requests, but I want to create a collection. So yeah, I give my collection a name. Yeah, as you can see, it's highlighted here. Just say node demo to change. Then inside my collection, I'll come here. I'll click this. I'll come. I'll say folder. I'll create a folder. You can just create a request if you want directly. No big deal. So here I'll just call. I'll just say um, requests handler. You can call it anything. Then inside this folder, I'll now add a a request. Now I want to add a get request. There are different types of request. There is post, there is get, there is put, there is patch, there is delete. Okay, so just call it to get response. Now I'm going to put HTTP localhost port 5000. This localhost is like it's normal because I'm running it inside my laptop, inside my system, so it's localhost. But this 5000 is the port. This 5000 is the port I must use. Is this port that I specified here. If I use another port, it won't target, it won't come to this server. Alright. So that's about that. If I run the request now, you're going to see the response. So let me click run. So guys, this is it. Hello from Node server. Hello from Node server. So guys, we have created our first backend server, and you can confidently call yourself a backend developer.
Sorry, I was going to ask, can you hear me?
Yes, I
If
can
we
hear you.
paste that link in a browser, what happens?
Yeah, if you put it in a browser, it will work. Okay, let me go
Oh,
to my
okay.
browser. Because it's a get request, it will work. See, hello from Node.js, from Node server. Now it will work. But if I give you now, it's localhost. I can't. It's not hosted on the internet, so nobody can access it. That's why we have Postman. Postman is just locally, and you can like on the browser now. I can. This is a get browser sends. If you paste the link here and you click enter, right? It's a get request. You can't send post request from this URL. All right. There's post request. There's push. There's put. There's patch. There's delete. There's. So we're going to do that. We're going to demonstrate everything here. All right. So guys, moving on. I think we have created our first node server. Okay. All right. So there's something I want us to do because our project is going to be in class. So let's see if we can convert this simple code now into a class. Are you guys with me? Let's see if we can convert it into a class and see if it will still run. Okay. So but before we do that, let me see. Okay, let's go there. Let's do that. Okay, let me create another. Let me cut this server so it's no longer running. My if I since I've cut it, I've stopped the server. If I click this now, it will not return anything. Okay, it will tell me not connecting because it's no longer. If I go back to the, if I do this now, it's just it will not return anything because the server has stopped. Okay, so let's do something. Let's transform to a class. Okay, so first things first, we'll do our imports. Come here, import the same things we imported. Guys, are we tired or should we just leave this class till tomorrow? Okay, guys, let's leave it tomorrow, right? We have created our server on
Yes,
a,
please.
yeah, Node.js.
My
Yes,
brain is loaded already.
yes. So tomorrow, we're going to, guys, we're going to create a
Yeah,
like a,
tomorrow is fine.
yeah, we're going to create a cool a CRUD. In fact, from tomorrow we won't be doing much of explanation again. It will just be implementing. You're going to be implementing, right? Implementing. So no more explanations, showing of slides. You're just implementing, right? So guys, thank you for coming around. Tomorrow, the same time, we'll kick it off. We'll convert. What we're going to do tomorrow is we're going to convert this one. Now continue from here, like converting to class. Then after that, we'll now do CRUD. We'll now do CRUD process. You guys know what CRUD is about. CRUD is create, read, update, and delete. We're going to do it here. Like you create an endpoint, a server that will do CRUD process. You create a user, you read the user, you update the user, and you delete the user. We're going to do it. Then when we do that, we'll now connect it. We'll now connect it to database, MySQL database. Then when we do that, man, we'll now do it. We'll now go into Express.js. Then when we do Express.js, we'll now build our projects. Then after building the project, we'll now take the project code and put it in the Express project code, take it and put it inside Nest.js so that you see how they relate. So in this program, you're learning a lot of technology. You're learning Nest Express.js. You're learning Nest.js. So the two are very marketable. If they call you for Express, you are there. If they call you for Nest.js, you are there. Then you're learning MySQL. MySQL is also translatable to Postgres. You can do the two. Then after that you can we will learn Redis. Then after Redis, we'll learn Kafka. After Kafka, you will learn Docker. Guys, when you are done with this class, you can just go anywhere and look for a job and get your job, bro. That's the main thing. All for free, guys. So thank you for today. Tomorrow we start continue from where we stopped and 1 p.m. All right. Of course, guys, of course. And the thing there is that you guys should not look like don't compare me to you. Like I am here to teach you, and one of the things I will teach you is the mistake the mistake I made in my career, like coming on. I'm going to teach you how not to make those mistakes. All right, like to avoid some kind of mistake so that you go higher than anybody. That's the main thing about teaching. My 5 years of experience. I'll give it to you. So that you start from there. All right, that's basically the main thing here. Okay, so thank you guys. If you need me to help you debug anything, you can message me. If I don't have time, I will tell you. Then anytime I have time, we'll trash it out. Anything. Okay, guys. Thank you very much, and see you tomorrow. Have a lovely
Uh,
weekend.
all right. Thank you very much, Christian. Thank you
Okay,
very
okay.
much. Yeah.
Christian,
And
thanks. We appreciate.
I also think that in the case of maybe debugging, trying to solve issues,
Yeah,
I think they can actually drop it in the group so that maybe
exactly.
within ourselves can also attend to it so that we lessen the workload on you, basically.
Okay, exactly. That would be great. That would be great. If anybody has anything, so because I don't, they should not derail the group. If you can drop anything relating to maybe you are programming and you find a bug and you need help, you can drop it in the group. No problem. I won't penalize that. That's main thing itself for the group, but not you are advertising for somebody to come and go and click one link for you. No, I won't appreciate that in the group. Just the group is for development. If you have any bug, anything you want to work on, drop it there. All right, guys. Thank you. All right. Bye bye.